welcome back. In this video we're going to introduce the topic of forces. I'm sure that you've heard about the word force being used. We're going to talk about forces in different videos, so it's important to refresh from one video to another and to keep on building on it. Okay? So to start off with, what is a force? How can we explain what a force is or define? Well, defined simply, a force is a push or a pull that one object performs on another object. That is what a force is. And there are different types of forces that we shall be meeting through our studies. Okay, and here we're going to have a look at some of these forces and some examples of different types of forces. For example, we have contact forces. Forces which are observed when two forces are physically touching each other. Two objects are physically touching each other. For example, in the picture over here, you can see a man doing some push-ups. So we have a contact force between the man himself and the ground. He's pushing up on the ground. Another type of force is a magnetic force, such as the one we find on our magnets in the laboratories, or even on the fridge magnets. Okay. Or in other examples where we find magnets, which we shall learn and see later on when we cover the topics of magnetism. Another force is the gravitational force. For example, it is the force we find between the Earth and the Moon, the force which is responsible for the Moon going around the Earth. Another type of force is tension, which we usually find in the likes of ropes or strings, for instance. Okay. So how is a force represented? Well, the SI unit of force is the Newton, and its symbol is the capital letter N. So for example, we have a force of say 50 newtons or 500 newtons or 5000 newtons. Okay. Now, if you may recall from the video on units, the Newton is not one of those 7 basic units that we had mentioned. But nevertheless, we can still express it in terms of those units. And in fact, the Newton is an example of what is called a derived unit. Sometimes it's complicated to express quantities in terms of their basic units only. So we used derived units because they're more representative and they're easier to understand. Alright? And depending on your level of physics, you may need to deal in some depth on these derivations, but not for now. For now, we'll just consider the Newton as it is. So, Newton, capital letter N. And remember, it has to be a capital letter N, not a small letter n. It is in fact named after a very famous scientist, Sir Isaac Newton, and we will be mentioning some important theories of his very soon, because Newton contributed a lot of important theories in both mathematics and physics, but in our case, we'll be seeing a lot of his theories in physics. Can we actually measure a force? I mean, do we have an equipment that can measure a force? Or is it something that we only calculate through a formula? Well, in fact, there is a piece of equipment which can be used to measure directly a force. The most common name for this equipment is a spring balance. It does have other names like Newton balance, Newton spring balance, but usually spring balance is something that we find it more commonly. The spring balances will be something like you're seeing over there in the pictures, which will be literally a spring, okay, and you will have a hook at the end, and you will place or try to pull the hook or place a load on the hook, and it will return the number of newtons that you are affecting. Some of these are in kilograms or grams, some of them are in newtons, some of them are both, okay. And you find a wide variety of them. But remember that as an apparatus, to measure force, we have the spring balance. Now, in many situations that we have, both in terms of physics in general and in terms of our questions in exams, we need to understand, appreciate, and at times even draw what are called force diagrams. Force diagrams is force diagrams are situations where we're given, for example, a picture like a table and a vase that you see over here, and we are asked to draw the forces which are, for example, on the vase. What forces exist on the vase? The representation of those forces is called a force diagram. For example, in this case, we have the weight of the object, the weight of the vase, which is pointing downwards because weight comes from gravity and it is the gravitational pull, it is downwards. We'll talk about weight later on. And you also have the reaction force. The reaction force comes from the contact. The physical contact between the vase and the table. So in that case, the vase is stationary and you have those two forces acting on it. Now, be a bit careful in the way that you draw these force diagrams. For example, the weight always originates from the center of gravity of the object. Again, center of gravity is something we'll talk a bit later on, but as you can see, the weight is being drawn from the center of the vase, right? Because most of the times we take the center of gravity to be the center of the object. The reaction, on the other hand, is drawn from the contact point, not just drawn randomly throughout the vase, right? I mean, these are details, they're small details, but they are important details. Also, again, depending on your level of physics, the length of the arrows you draw is also important. A length of an arrow indicates the size of the force. Here, they are approximately the same, which is fine. Okay, but there will be situations, especially in higher level of physics, where it is important to distinguish between the sizes of the arrows, right? So keep these in mind. Now what about this? You have a man driving a car. Okay, you can see that it's driving towards the left. What forces do you think exist in this case? Can you think of some forces? Let's see. Well, this is a little bit more complicated because we've got a moving object, as you can easily see now from the force diagram over there. Okay, if the car is moving to the left, you need something which is pushing it, which is making it move towards the left, and in the case of a car, for example, that would be the force we have in the engine force, right? But anything which moves in air, right, will have resistance from the air surrounding it. The air particles cause resistance, and hence on the opposite side we've got acting against the motion. You can see the air resistance because that is slowing it down, right? We also have the weight because, like anything on earth, it is pulled down, so there you have the weight. You have the reaction with the tires because the tires are in contact with the ground, and so they have a reaction force. Each tire has a reaction force. And then finally over there we've included also the friction, because as the car is moving, the tires observe friction with the road. Okay, so that is a nice force diagram, which is rather complicated, you can say. Another example, the last one for this set. What about this? An aeroplane. An aeroplane which is flying. What forces do you think exist on the aeroplane? Any ideas? Well, as you can see, again, we've got a nice force diagram. You've got the engine force, which is pulling the aeroplane in the direction it needs, or the thrust, the engine thrust, okay? You also have the weight, because like any object, again, on Earth, it observes the weight, okay? Now, in this case, there is no friction as such, because it is in air, it is not touching the ground. Friction is more the word we use when two objects are physically in contact with each other, two solids. When we're talking about something moving in a fluid, okay, in air, in water, we usually use the word drag. Air resistance is one form of drag, but it is not the only form of drag. If you have a boat in the water, you don't have air resistance from the part of the water, but you have its drag. Alright, so keep these words in mind. Now again, here we don't have any reaction force because in this case the plane is not physically touching the road or the runway, it is flying in the air. So in this case the upward force is what is called the lift. Okay, on a boat we have something similar, it's called an upthrust. So, right, so all these are new words which you would do well to research a bit about them also. Well, that's it for this lesson. This was rather a short video, but in this video we introduced an important concept. We introduced the idea of forces, okay, and we shall be going into more detail on forces in other videos because it is a very important and quite a big topic in physics. Okay, so make sure to keep a good eye on this. Hope you like this video, and as always, thank you for watching.